The Milky Way galaxy and Andromeda galaxy are coming closer together every minute, every second, and eventually they're going to merge. The Andromeda galaxy, M31, and the Milky Way galaxy, two of the largest galaxies in the local group, are on a collision course that will unfold over billions of years. While many think of galactic collisions as catastrophic explosions, the reality is far more graceful, like a slow-motion dance that stretches over immense timescales. Evidence shows that this collision has already begun. As these two galaxies approach each other, their gravitational forces are beginning to reshape both systems, initiating changes that will have far-reaching effects on the stars, gas, and other cosmic components. When you think about the universe, it's easy to imagine galaxies moving farther apart due to the expansion of space. After all, that's what the Hubble Space Telescope has shown. Galaxies receding from each other as distant galaxies appear to shift toward the red end of the spectrum, a phenomenon called redshift. However, the Milky Way and Andromeda are part of a unique situation. These two galaxies are relatively close to one another, only about 2.7 million light-years apart, so the universe's expansion doesn't affect them in the same way. The force of their mutual gravitational attraction is far stronger than the expansion of space at such a close range. Gravity, the fundamental force that governs cosmic motion, pulls them toward each other at a mind-boggling speed of 123 kilometers per second, roughly 76 miles per second. This rapid movement is setting the stage for a galactic merger that will completely reshape both galaxies. While such a collision may sound like a violent catastrophe, the actual process is much more gradual and graceful. As galaxies are mostly composed of empty space, the stars themselves are unlikely to collide. Instead, it's the gas, dust, and dark matter that will interact, leading to stunning new formations and cosmic phenomena. One of the first signs that the Milky Way and Andromeda have started interacting is the discovery of hypervelocity stars. These stars are traveling at incredible speeds, up to 1,000 kilometers per second, fast enough to escape the gravitational pull of their home galaxy entirely. But how do these stars reach such high velocities? Several mechanisms can cause stars to reach these tremendous speeds. In binary star systems and near supermassive black holes, a binary star system is when two stars orbit around a common center of mass. If such a system gets too close to a supermassive black hole, the gravitational forces can disrupt their orbits. One star may be drawn into the black hole, while the other is ejected at a speed so high that it escapes the galaxy's gravitational grip. This process, known as slingshotting, can propel a star to hypervelocity speeds. Additionally, when galaxies collide or pass near each other, their gravitational forces can eject stars from their homes, especially in dense regions where stars are closely packed. The interaction between galaxies, specifically the gravitational forces at play, can disrupt the motion of stars, pushing some of them out of their home galaxies entirely. Astronomers believe that many hypervelocity stars in the Milky Way have been kicked out of Andromeda in a similar manner. Simulations and data from missions like Gaia, which is mapping the positions and velocities of stars in our galaxy, support the idea that Andromeda's gravitational influence is already beginning to reshape the Milky Way's stellar population. As astronomers continue to search for these high-speed travelers, they uncover more evidence that the Andromeda-Milky Way interaction is well underway. In addition to hypervelocity stars, astronomers have found another clue that the galaxies are interacting: the collision of their galactic halos. A galaxy's halo is an invisible, diffuse region of gas, dust, and dark matter that surrounds it, extending far beyond the visible stars. Though halos do not emit light, they have mass and are crucial in the dynamics of galaxy formation and evolution. The Andromeda galaxy's halo is particularly massive, extending over 1.3 million light-years toward the Milky Way and up to 2 million light-years in some directions. Despite being invisible to the naked eye, the gas and dark matter in the halos still have profound gravitational effects on the galaxies themselves. In groundbreaking research, astronomers using the Hubble Space Telescope studied the light from quasars situated behind Andromeda's halo. Quasars are incredibly luminous objects powered by supermassive black holes at the centers of distant galaxies. As the light from these quasars passes through Andromeda's halo, it is absorbed by the gas and dust in the halo, revealing detailed information about its composition and structure. What astronomers discovered is astonishing. Andromeda's halo is so extensive that it overlaps with the Milky Way's halo. This overlap indicates that the two galaxies are already in the early stages of a cosmic collision. Though the stars within the galaxies are still widely separated, their gas and dark matter halos are beginning to interact, marking the beginning of a gradual and long-term merger. This discovery adds further evidence to the idea that the Milky Way and Andromeda are already engaged in a cosmic dance that will shape their futures for billions of years. The dramatic effects of the Andromeda-Milky Way merger will unfold over billions of years, starting with an initial close encounter around 3.75 billion years from now. As the two galaxies pass through one another, their gravitational forces will cause their shapes to distort, triggering immense bursts of star formation as gas clouds collapse under intense pressure. This period of rapid star birth will likely be accompanied by the formation of new stellar clusters and even some stellar remnants like neutron stars or black holes. As the two galaxies continue their slow-motion collision, the night sky will become a breathtaking spectacle. Andromeda, which is already visible from Earth as a faint smudge in the night sky, will gradually grow larger and larger, spanning the sky for hundreds of thousands of years as it comes closer. The two galaxies will eventually separate, but their mutual gravitational attraction will pull them back together for a final catastrophic collision about 4.5 billion years from now. This final merger will likely result in the formation of a new, larger elliptical galaxy, often referred to as Milkomeda. At the heart of this new galaxy, the supermassive black holes of the Milky Way and Andromeda will merge, forming an even more powerful black hole. The stars and gas in both galaxies will be reconfigured into an entirely new structure, possibly leading to the formation of new star systems or the ejection of some stars into intergalactic space. As for our solar system, its fate remains uncertain. It could be flung into the outer regions of the new elliptical galaxy or even ejected into the vast emptiness of intergalactic space. Though this dramatic event will unfold long after humanity's time on Earth has passed, future generations of humans or life forms that may evolve from us could witness the dramatic changes in the night sky. The eventual merger of the Andromeda Galaxy and the Milky Way is one of the most awe-inspiring events in the universe's future. Though this cosmic collision will take billions of years to fully unfold, it is already underway, as evidenced by hypervelocity stars and the overlapping halos of the two galaxies. While the immediate consequences may seem distant, the process itself is a testament to the dynamic and constantly changing nature of the universe. As galaxies collide, merge, and evolve, they shape the cosmos in profound ways, reminding us that the universe is anything but static. It is a living, breathing entity, constantly transforming and evolving. The merger of the Milky Way and Andromeda will forever change the night sky, and it's just one of the countless cosmic events that highlight the majestic and infinite nature of the cosmos. As the Milky Way and Andromeda continue to approach each other, their interaction will not only reshape their structures but also have far-reaching consequences for the galaxies within their spheres of influence. Over the course of billions of years, this cosmic dance will alter the position, motion, and nature of stars, gas, and dark matter in ways that we can only begin to comprehend. It's important to note that the process of galactic mergers is not a rapid or instantaneous event. Instead, it is a series of carefully orchestrated cosmic events, each unfolding over immense timescales that allow us to study the galaxies involved, even from our vantage point on Earth. One of the critical aspects of this cosmic collision will be the transformation of the stars that are a part of the two merging galaxies. Throughout the merger process, both galaxies will experience bursts of star formation. These bursts will be fueled by the massive amounts of gas and dust colliding and compressing as the galaxies pass through each other. When gas clouds collide at high speeds, the intense pressure and heat cause the gas to collapse, leading to the birth of new stars. This rapid star formation will create an entirely new generation of stars, some of which will be massive and short-lived, ending their lives as supernovae. These explosive events will scatter heavy elements like iron, calcium, and oxygen throughout the merging galaxies, enriching the interstellar medium and providing the building blocks for future generations of stars, planets, and potentially even life. In addition to the creation of new stars, The merger of the Milky Way and Andromeda will also likely lead to the disruption of existing stellar systems. The gravitational forces at play during the collision will pull stars out of their orbits, either ejecting them into intergalactic space or altering their paths within the galaxy. Some stars may even be captured by the supermassive black hole that will form at the center of the new merged galaxy. This chaotic environment will make it more challenging for planetary systems to remain intact, as gravitational disturbances could displace or destabilize the orbits of any planets in existence at the time. Another fascinating aspect of this galactic merger is the potential for the creation of new stellar remnants. As the galaxies collide, massive stars will burn through their fuel more quickly, leading to the formation of neutron stars or black holes. These dense, compact objects will contribute to the complex gravitational landscape of the new galaxy. Some of these black holes could merge to form even more powerful gravitational sources, potentially emitting gravitational waves that may be detectable by future generations of astronomers. The formation of these new stellar remnants will further enrich the content of the merging galaxies, influencing everything from the motion of stars to the formation of future star clusters. The intergalactic space between the Milky Way and Andromeda may also play an interesting role in the merger. As the two galaxies collide, the space between them will be filled with a chaotic mixture of gas, dust, and dark matter. This region, though largely invisible to the naked eye, will experience an increase in activity as gas clouds are compressed and heated, potentially leading to the formation of new, smaller galaxies or the acceleration of cosmic phenomena like supernovae. The intense radiation and energetic events taking place in this vast region of space will further fuel the cosmic cycle of birth, death, and rebirth that is central to the universe's ever-changing nature. The fate of the gas and dust in the intergalactic medium is also of particular interest to astronomers. As these materials are drawn into the gravitational wells of the merging galaxies, they will contribute to the transformation of the galactic environments. The gases will be funneled into the supermassive black holes at the centers of the galaxies, likely fueling the formation of active galactic nuclei or quasars. These luminous objects, powered by the immense gravitational energy from the black holes, will shine brightly across the universe, providing astronomers with valuable insights into the inner workings of galactic mergers and black hole growth. Additionally, the collision between the Milky Way and Andromeda will have implications for the larger cosmic structure that they are a part of. The local group of galaxies, which includes both the Milky Way and Andromeda, is currently part of a larger cosmic web of galaxies, clusters, and superclusters. The merger of the Milky Way and Andromeda could affect the dynamics of other nearby galaxies, potentially leading to the reshuffling of galaxy groups or even the creation of new galactic clusters. As galaxies merge and interact in these cosmic ecosystems, they help shape the structure of the universe on the largest scales, providing key insights into the nature of dark matter, dark energy, and the expansion of the universe itself. In the long term, the merger will result in a massive elliptical galaxy that will be vastly different from the spiral galaxies we know today. The new galaxy, often referred to as Milkomeda, will be a completely restructured entity with an entirely new arrangement of stars, gas, and dark matter. This new galaxy will likely have a much more spherical shape than the current disk-like structures of the Milky Way and Andromeda. The end of the merger process will mark the culmination of billions of years of cosmic evolution, but it will also raise new questions about the future of the universe. While the merger of the Milky Way and Andromeda is still many billions of years away, the process offers a fascinating glimpse into the dynamic, ever-changing nature of the cosmos. It highlights how galaxies are not static entities but are constantly evolving through interactions with one another. These cosmic mergers contribute to the ongoing reshaping of the universe, bringing about the birth of new stars, the formation of new galactic structures, and the ongoing transformation of the cosmic landscape. The eventual merging of these two galaxies serves as a reminder of the scale of time and space in the universe, offering a humbling perspective on the lifespan of our own galaxy and the Earth itself. For now, we can only marvel at the distant future of the Milky Way and Andromeda, knowing that we are living in a tiny moment of the vast and ever-changing cosmos. As the Milky Way and Andromeda continue their cosmic dance toward merger, the interaction will extend far beyond just the two galaxies themselves. The immense gravitational forces exerted during the collision will likely cause distortions in the surrounding cosmic environment, including the influence of nearby galaxy clusters. The collision may trigger a cascade of events, including the acceleration of other galaxies in the local group, possibly altering their trajectories as they are drawn into the merger. Smaller galaxies could be captured by the gravitational pull of the merging systems, adding their stars and matter to the growing mass of the new elliptical galaxy. In addition to the effects on neighboring galaxies, the merger will have significant consequences for the vast dark matter halos that surround both galaxies. These halos, which contain a majority of the galaxy's mass, will likely interact and merge in ways that could reveal important new insights into dark matter, a mysterious substance that makes up a large part of the universe's mass but remains invisible to traditional observation methods. Understanding how dark matter behaves during such a galactic merger could be key to unlocking more secrets about the universe's underlying structure and its ultimate fate. The merger of the Milky Way and Andromeda will also mark a pivotal moment in the ongoing evolution of galactic ecosystems, continuing to shape the cosmos in profound ways.